Okay, so this is the first video of a series that we will do. So just a small video with a simple example explaining how to use the workbench. So let's just start. So this is the window that opens when you open the workbench. You have several menus here. So this here you can save or archive, import some file. Here you can change the view in this window and add other stuff. So here you can change the units. Here you can go to the help and you have several different options here, so you can explore a bit. Here are the different models that you can do. So we have static structural here. Then you can do steady state thermal, also transient structural. All of these you can use. So for this example, to we are going to use the international system. So this is the one. So let's go to static structural. And as I said, you can add different models in the same project. Also steady state thermal. And then here you can move them as you want. You click on this and hold, and you can position them for here, and you can connect these two. So, and yeah, that's an example. So, but for now, let's just focus on this static structural. So we'll delete and also this. So first of all, let's save it just in case you always have to save. And go here and then just put first simple example, and that's it. So here will change, so you see it's saved. So let's first start by defining our material. So here this is a default material used in Ansys structural steel. But if you go here, engineering data sources, you also have other types of materials. You have additive manufacturing materials, so you have here the list, different libraries, so also thermal materials, and you can choose from the list what you want. But in this case, you can also add materials, so we will add stainless steel. So 3 of 4, and I will define. So this will be a linear elastic analysis. And here, so let's see what is. So Young model is 200 gigapascal. And the Poisson ratio is 0.27. It's done. Let's save it again. For the geometry, we can do a small bar. Let's design it in space claim. Still opening. It's a bit slow. So let's draw the bar. So we choose rectangle. And that's it. So after that, we use the pull tool to do our bar. Let's define 1,000. And that's it. So we open the model. So this is the window that opens when you open the model. So you have several menus here, so you can add also here different analysis as we saw before. Here you can change the units. You can you can check the print preview, have several stuff here. This button is to solve. Then here is the model options, so you can also add the section plan, symmetry plans, and also yeah, you have here is the display options, and yeah, you can export this more if you want. So first of all, let's change the unit to the same that it's okay. So here in the geometry, so this will be a linear analysis, so we need to change this to no. And also here you can, the thermostrain effects, it will also change to no. So, but you can either choose it from the list or just double click. And here you need to assign the material that you want. So, and then we go to the mesh. We will try with the default mesh to see what we get. So yeah, it's a bit harsh. So let's decrease a bit the size of the elements. So and here maybe we put 10 and see what we get. Yeah, much better. Yeah, so normally you should have at least 2 elements for the thickness, so this is good. Now we will define the boundary conditions. So let's put a fixed support in this side and apply a force of, let's see. So for example, in this edge of maybe 100 newtons, just to see. So let's solve it. So it's solved. So we can check the deformation and also for example, the von Mises stresses. So let's evaluate. It's done. So let's put this. So let's see. So this is where it's applied the force, and here is the support. So the total deformation is 13 more or less, 12.5 millimeters. And here the result, you can also show the undeformed. You can change it as you want. Okay, so here you can see the undeformed shape and the deformed shape. But this is too, let's put it.
So this is the true scale. So you can see here the undefined model and then the deformation and the maximum, of course, it's here. And the stresses, you have it here. So it's much higher near the support, of course, with a stress of 79 megapascal. Yeah, so that's it. This is a small example just to show you a bit how to work with Workbench. So let's just save it. And that's it. Thank you guys.